Longitudinal waves have different properties to transverse waves because of their nature. They can reflect off surfaces and be diffracted, just like any other kind of wave. They can suffer from interference in the same way transverse waves do. The only way to tell the difference between a transverse and longitudinal wave is whether or not they can be polarized. Longitudinal waves are pressure waves. They are formed when a patch of air or grouping of particles is given a shove in one direction. This causes the particles to bunch together and increases the pressure in that region of space, or that region of the medium. The amount of mass in a certain volume has increased, and so the pressure has increased. In order to do this, you have to have taken particles from somewhere else. This happens behind your initial shove. You have taken the particles from this section and pushed it into a more dense section. This means that there are fewer particles in that region, and so the pressure has decreased. The high pressure area moves forwards, squashing particles together in front of it and spreading them out behind. This is a typical description of a longitudinal wave. The only difference in types of longitudinal wave is the medium in which the wave is travelling. If the longitudinal wave is travelling through the ground, then it is a type of seismic wave or earthquake. If it is moving through water, then it's a special kind of water wave, like a jet of water. If the wave is in air, then it is a sound wave. The different varieties of sound wave are down to the gas that the wave is travelling through, and the wavelength or frequency of the wave. If a sound wave travels through helium, it travels faster as the particles are closer together. This means that the wave fronts are close together, and the sound is of a higher frequency. That's why your voice goes squeaky in helium. A lower tone sound is a lower frequency wave, which means that the frequency of the wave is lower and the wavelength longer.